Hi everyone, my name is Junaid Alam. In this video, talk about my 6.3 HD editors, which based on the QUIC protocol. So QUIC is a modern solution that makes the internet faster, safer, and more efficient. So in this presentation, I will I'll talk about this. So here's we'll covering to what we're covering today is the first we'll introduce the key UIC and why it was created, and then it will explore the features and will compare the TCP with the TCP or TLS with the key UIC, and who is and also will include who is using this today, and we also dive into the security and cryptography inside QUIC. We will discuss some real-world problems and wrap up with the Wireshark demo and summary and reflection. Let's move to the next slide. So QUIC stands for Quick UDP Internet Connections. It was developed by Google to improve web browsing speed and security. Unlike traditional protocols and protocols like QUIC runs on UDP and merges multiple layers like TLS and transport into one streamlined system. It's now a global standard used across many platforms. So the reason behind the creating the KUIC is basically uh, traditional protocols like TCP and TLS are readable but slow. They need multiple handshakes to before data can be securely transferred. This delay is especially noticeable on mobile networks. KUIC was created to fix this, offering faster connection setup and encryption from the first packet and the smooth handling of network changes like switching from Wi-Fi to mobile data. Let's move to the next. So basic features of QUIC. QUIC has five key features. First, built-in security. TLS 1.3 is integrated from the beginning. Second, faster setup using the 0 to RTT or 1 to RTT. Third, multiple multiplexing, multiple stream without interface. Fourth, IP mobility, keeping the session active when networks change. And finally, because it's run in user's space, updates can be deployed much faster. Yeah. So let's talk about the difference. So with TCP, we have a layered architecture. The TCP for transport, TLS for encryption. This setup needs to be is at least two round trip. So plus TCP suffers from head of line blocking. One delayed packet can freeze all others. In contrast, the QUIC integrates all these functions into a single protocol. It's enable zero to RTT setup, avoid blocking with the independent streams, and updates faster thanks to use space deployment. So who is the today's user of QUIC? So QUIC has been approved by major companies like Google uses it for Chrome Google search and search in Google and search, and Meta uses it for Messenger, while Cloudflare supports it by via the HTTP, and WhatsApp uses QUIC for secure voice and video calls. Uber uses it for its mobile app for faster API response. These companies trust QUIC for speed and reliability, especially under mobile conditions. So security benefits. QUIC enforces TLS as 1.3 in every connection, ensure strong security is it encrypt more than traditional TLS, including packet number and system IDS. It protects users' privacy and limits matter metadata exposure. It also prevents attacks like man-in-the-middle replay attacks and downgrades attempts, all from the very start of the connection. Okay, cryptography inside the KUIC. The KUIC uses a head encryption such as AES GCM or CH Chacha 20 Polai 1300. So these algorithms provide confidentiality, ensuring data is hidden integrity to prevent tampering and authentication to confirm both sender and receiver identities. So what sets QUIC the appear is that encrypted feature are built in, not layered on top like in TCP. Threats and how QUIC handles them. So QUIC designed to counter common threats, replay attacks are blocked using the Unix tokens and timestamp packet injection to become prevented because every packet is encrypted and authenticated. KIC also protects against connection hijacking and traffic analysis by encrypting session details, and making patterns hard to detect. Let's move to the demo. In the demo, we're using the Wireshark. The Wireshark and the website you are using is cloudflarequick.com. Okay, so let's move to the Wireshark. So if you see the number of the 31, 32, and 33, these are the so it contains the crypto ping padding and the packet number pk and the these early packets are part of the quick handshake. They include frame types like yeah they include frame type like the crypto PMP, PING ping, and which are used to initiate and secure the connection. QUIC performs TLS 1.1.3 handshake detect directly inside the transport layer, and which is much faster than the traditional TLS over TCP setup. If you see there, uh, 35, the row 35 and 36, 37, therefore everything is from same source. They contain the include SEK and optional padding. So quick uses GUIC uses SDK frames to confirm receipts of earlier packets. Unlike TCP, these are not ties the entire connection, but can be done per stream, improving readability and speed. If I move to the last section, uh, row 200, 1 to the 100, they uses the KP0. These are labeled as payload, as you see there. So it means most of QUIC packets data is encrypted as shown there. Wireshark can't show the inner detail. This is the protected payload, which includes app data like HTTP requests, but it's encrypted to prevent tampering and spying. At the end, we'll talk about zero to RTT packet. So if you see this one, yeah. So this labeled as 0 to RTT. So in here something this is something powerful. So this packets uses 0 to RTT, meaning the client sends data during the first handshake round trip. This greatly reduces its latency and speeds up the page load. That's all on the demo. Let's move to the slides again. Okay. So, in summary, QUIC is a powerful modern protocol that uses this message is that merge the speed, security, and the mobility. It solves many issues found in the TCP and TLS. It's already trusted by global tech leaders with zero RTT built-in encryption and mobile-friendly features. QUIC represents the features of internet communication. So in the reflection, while working on the project, I was doing the at the task. I learned how protocols in evolve to meet modern needs. I explored how TQIC enhance both performance and security, and I gained a hands-on experience using the Wireshark. This task helped me to understand how real-world design chooses affect user experience across the internet. And this is the reference list that I used for the task. Thanks for listening.